Hello, welcome to 3.4. We are going to be talking about the vertex form for absolute values. So let's get into it. All right, we're talking about the vertex form of an absolute value function. So before we get started, we've got a little bit of warm up, kind of a refresher from our last lesson. So we're looking at our absolute value parent function. So this is just your very basic absolute value. You put a -5 on the inside of it, it shifts right. So remember, anything inside the parentheses, in this case, the parentheses are our little absolute values, it goes the opposite of how you would think. And then anything, and it goes left or right. And then anything on the outside is going to go up or down. So we got a plus 9 right there, so it shifts up 9 units. So again, this is just kind of a refresher. You know, we've got our negative sign on the outside, so it's reflected on the x-axis. That's going to look something like that. And then, of course, we've got our vertical compression by 1/4. I didn't write that. And then this is going to go left 6. So again, these are just our transformations that we went over last time. So what's neat about the transformations, at least the translations, that's when it's moving up or down, left or right. So those things actually will give us the vertex, up here, the vertex of our absolute value. So our vertex will start at 0, 0, and then if it shifts up 1, our vertex, or up 2, our vertex will move there. If it shifts to the left, our vertex will move there, and then we just draw our graph like that. So that's kind of a cool pattern, right? So how do we up that pattern to make it a little bit more useful? So that is what the vertex form of absolute value is. Basically, do you remember how we had a line? We had it in standard form, and that's all well and good, but you couldn't get a lot of information out of it. But then we put it into y equals mx, or slope-intercept form. So this is that version. So if we set our absolute value up in this kind of situation where we have our absolute value plus or minus something on the inside, plus or minus something on the outside, and maybe a number on the outside, that gives us a lot of information that we can graph straight from that equation. We don't have to do the tables. We don't have to do points. We can just pull all of that off. So let's dissect it a little bit. So we've got our h and our k. So we've got h and our k. So that tells us our vertex. That's our vertex. Now, something to note, there is a minus sign on the inside of here, okay? So that means that when we look at the vertex, our h number is going to change sign. So we'll see that in the examples, but I just want to bring that to your attention right now, that there is a negative sign right here that is going to change the sign of our h value. So we look at our h. This is going to be our x, which that makes sense because our inside here moves it left and right. Okay, so then that would be the x-axis. And then we've got our k, which is on the outside, is going to be our y-axis. Again, that makes sense because the outside numbers move it up and down. So, okay, and then we've got this number out here, this a. This is actually kind of convenient to know, because hopefully you've kind of seen that like the absolute values can either be like really narrow or really wide. So this number tells us how wide or how narrow, and we can graph it because it is the slope on the right side of the absolute value. And by definition, negative a is the slope on the left side, but usually I just graph the right side and then just mirror it if I'm graphing, because it's just easier that way. So the main takeaways here is notice that the h is a negative sign, goes to our x value, our k goes to our y value, and this is our slope on the right side of our absolute value. Okay, so let's do some examples. Graphing these things becomes a whole lot easier now that we know the vertex form. So we're looking at number 1. So first of all, we can look at this number and that number, and we already know the vertex. So my vertex is going to be at 2, -4. I just know that from looking at it. Remember, there is a negative sign in front of the h inside of there, so this number changed signs. So notice how that is a positive 2, even though it started as a negative 2. So that x value changes signs. I'm going to say that over and over again because what's the most likely mistake? We forget that negative sign. Okay, so we've got our vertex. So x is 2, 1, 2, 1, 2, 3, 4. There's our vertex. The a is, there is no number there, so it's an implied 1. So our slope is 1 over 1. So I can put a few points there. I kind of missed, but whatever. And I'm just going to mirror it on this side. And there you go. Done. See? It's that easy. So if we go to the next one. So again, we've got a positive 5 on the inside. But remember, that sign switches. That flips. So our vertex, our x value is going to be negative 5. And there's no number out here. So there is an implied 0. So when you don't see that number, it's a 0. Not to be confused with if there's no number right there, that's an implied 1. The difference there is if you're adding or subtracting, and it's gone, then it's 0. If you're multiplying or dividing and it's not there, but the number, like the variable is still there, then it's going to be a 1. So that comes from that understanding of kind of multiplication and stuff like that. Okay, so we have an implied 0, so that means our vertex is negative 5, 0. 1, 2, 3, 4, 5. And then our slope here is going to be 3, so that's the same as 3 over 1, rise over run. So 1, 2, 3 over 1, 1, 2, 3 over 1. We connect those dots. I'm going to make a mirrored version over here. And done. 1 and 2, we're good. So again, this vertex form helps us to graph absolute values super easy. So I skipped a couple of examples. We will definitely do plenty of examples in class. They're all kind of the same structure. So I skipped down to 7 and 9 because everybody loves piecewise functions. So we're going to graph this one in blue. We'll graph this one in purple. And again, piecewise functions, it's the same thing. You're just graphing normal things. You just have that boundary line. So on one side of it, you graph one of them, and on the other side, you graph the other one. So our boundary line in this case, I'll do it in red, is at negative 4. 1, 2, 3, 4. And then on our left, that's blue. So that's going to be just a line. So that's hopefully by this point, it's pretty easy to graph. So it's going to have a y-intercept at 7. 1, 2, 3, 4, 5, 6, 7. And we're going to go down 2 over 1. So I just added a negative sign to both the top and the bottom, which is the same as positive 2. And then we will keep going down 2 over 1, down 2 over 1, down 2 over 1. So remember, these blue dotted lines is kind of just pretend. The graph doesn't really start until it hits that boundary point right there. And then it's going to be an open circle because of this sign right there. So, okay, we'll do our absolute value on the right. So we don't need to throw any extra points at it so we already know the vertex of it. So our vertex is going to be negative 3, 0. So this number changed signs. There is no number outside of it, so it's an implied 0. So we've got our vertex at 1, 2, 3. And then our slope on the right side is going to be 2 over 1. So I'm going to go up 2 over 1. Oops. Up 2 over 1. So I can draw that line. Kind of missed, but that's okay. So then we went up 2, and then if I mirror that, we're going to go right up here, and we're going to hit that boundary. And we're going to stop at that boundary, and I'm looking at this sign. So it is going to be a closed dot. So that's our graph, piecewise function. Again, don't freak out. They're a little bit more challenging, but if you just chunk them out and do it step by step, you can do it. I have faith in you. So let's try an inequality. Okay, maybe you can kind of guess, see where this is going, but we're just going to graph this absolute value on number 9, and then we're going to do some shading. So step 1, what is our vertex? Our vertex is -4, -6. Again, this number changes signs. This number does not. So we're going to go 1, 2, 3, 4, down 6, 1, 2, 3, 4, 5, 6. So there's our vertex. Our slope on the right side is this number right there. There is no number there, so it is an implied 1 over 1. So I can just go boop, boop, boop. And we've got our straight line there. And we're going to just mirror it on this side as well. Close enough. So now the trick is, okay, we need to shade. By the way, because this is a less than or equal to sign, I'm going to leave this line and this line solid. If it were just a less than sign, then this would need to be a dotted line. However you choose to show that, I'm pretty happy with. Anyway, so y is less than or equal to my graph. So when I think about that, y is less than, that means that it's going to be down here, because y needs to be less than that. If that doesn't make sense, a second way to think about it is, as long as the y is on the left, this less than symbol is going to go down, greater than is going to go up. Or you can always plug in a point right here and see if it's true. So if I were to use the origin, I could just say, we'll do this in red. I could say, is 0 less than or equal to 0 plus 4 minus 6. So that's going to be 0 less than or equal to -2. Is 0 less than -2? No, that is a false statement. So we would shade away from the graph. Those are 3 different methods. You don't need to know all 3. Just pick the one that works best with your brain and become proficient at that. That's what you got to do. So there you go. Absolute values in vertex form. We'll do lots more examples in class, and it's going to be fun.